Hello, I'm back. Time for another electronics video. First off, I've made no more progress on Plum. This is still as far as I've got. This is the 3x8 bidirectional buffer or bus transceiver matrix module. This can take a 3-bit word and map it onto three 8-bit words, essentially. If you're interested in this, I made a video about it. Though I still haven't actually shown you it running or tested. So I should probably rig together some kind of test harness for it so that you can actually see what's going on. But that would be yet more stuff to do that would prevent me from making any progress. So maybe I will, maybe I won't. Anywho, we're back at electronics. So obviously it's not a screencast. I'm not going to subject you to another SED tutorial. I'm actually revisiting the segment timer project, of which I've also made bugger all progress, with one exception. So in the last video I did about this, I highlighted my concern around the fact that there were no slots cut out, these out of the circuit board, so normally around here, because you've got high voltage AC on this side and low voltage DC on this side. The other thing that you would also tend to see in these modules is opto-isolators, of which this one has none. I did find another module, which is this one. Again, it's an 8-way relay module, but this one, as you'll notice, has slots cut out. And it has the slots around the very pin that I would have expected them to have been on, and also no extra solder along the track, just really big chunky tracks. So I'm already feeling better about this one. This one also has opto-isolators on it. So we've got these clusters of, let me get the lighting right, these clusters of through-hole, of surface mount components here, and then we've got one through-hole component, which is the opto-isolator. Now, I have already had a test of this, and it all works. My thought was to just get something together now that works quickly, was to use one of these Arduinos. I don't know, is this a Pro Mini? Is this a Nano, a Micro? I'm not sure what it is. I think it's an Arduino Mini, because I seem to recall that the Arduino Nano is actually bigger physically than the Arduino Mini, which was always a bit odd to me. But anyway, I'll use one of these, and I've got one that I've already soldered the FTDI header on, which I use with this cable. Now, having the USB chip in the cable instead of on the circuit board is what can make these so much cheaper. You can get this kind of thing now. Have I got one to hand? I don't appear to. With a CH340 chip on it, I believe is the code for it, which is just a sort of alternative USB serial transceiver chip that you find on the cheaper sort of Chinese knockoff modules. But this has none whatsoever. It just has the TTL serial, so that's fine because I've got the cable. Cables themselves don't run particularly cheap, but it's one of those things that once you've got the one cable, you can use it with any number of different projects, and it's fine. So what I was thinking of doing was, if we have a look at this header array here, we see we've got, can you see this? There we go. We've got ground inputs 1 through to 8, and then VCC. Now, it kind of slightly matches up with a lot of the pins that are available on this. So what I was thinking of doing is just attaching this straight on like that. I can just get that on. Like that. So that leaves me having to hook up ground, but VCC lines up with VCC, and then inputs 1 through 8 are on these pins, 10, 11, 12, 13, analog 0, 1, 2, and 3. So I would lose 4 analog pins on this, but I'm making I don't need to be getting concerned about that for something like this. It'll do. And that just leaves me needing to hook up the ground, which is this one over here, to one of the other pins. So there's a ground pin here that I could use, or there's one up here which I could use. I'm not entirely sure which one I'll use yet, but that will require a little flying lead to go off to the ground, and then I'll have to solder on some leads to VCC and ground over here to be able to power the whole thing. But I think that will work. I think that will work fairly well, and I've still got room here to be able to plug in my serial header. So I'll be able to plug that in there to program it or to control it. And it will also leave the A4 and A5 open to me. Now these two being here is actually kind of convenient, because what I will do for those is I won't use this header. This one's a bit long, but I'll have some more. I'll pop a header into those two like that, and that will enable me to also use a real-time clock with this. And as you can see, these again have a fairly standard arrangement. Ground VCC data clock. So I'll be able to take the data clock, whichever way round it goes, and pop that onto there, and then, well, power and 5 volts and ground will go in there somehow. I'll figure something out. And I think, just for good measure, I'll still put in a strip of headers on the end there, so that I can add some extra things into it if I so need. So yeah, let's do that. So I'm just having a look at this jumper here, and it seems that all it does is pass VCC over to one side of all the opto-isolators. You have a look at that track. Goes to the middle, and then the pin on the right goes down to the left-hand pin of the bottom pair of all the optos. So I think what I'm going to do is just bridge those two together on this side. That way we don't need the jumper, and I'll be able to use those pins as a power port for any of the I2C modules, a real-time clock or a display that I might want to add. So I think I'm going to do that. And I think that'll do. Just check it. Oh yeah, that's not too bad at all. Now I can just chop off that extra header. Well, that's gone forever. So it seems I didn't actually have the camera on when I was bending this piece of wire to go off to the ground pin. But there it is. That's the only piece of bent wire in this project. I do like bending a piece of wire though, and I think that looks quite tidy. So I'm pleased with that. So let's get that on there. And I'm pretty sure That angle is going to be spot on. Oh wait, well, it's a little bit off. I don't think it's close enough. I thought I'd try for a detailed close-up at this point, but sadly that was not to be. Yeah. No! Damn it! I got carried away. Shouldn't have soldered that on just yet. I didn't put the header in here. I wanted to put a header there and a few more on there, so... Okay, let's undo this. Control Z! Control Z! Where is the box of headers? Hooray! Some of these. And one of these to make life easier. Because I've already made my life more difficult than it needed to be today, so let's try not to repeat the mistake, eh? So, if I just pop that there, will that reach? No, it won't. Okay, so I need to just raise them up a bit. Cannot be fully plugged into the breadboard. There we go. Can I get something else just to prop it up a little bit? Just so that the board is balanced and that I solder those headers on straight. And that looks close enough. Well, that's not too bad, I suppose. One of those looks like it may have come out of the factory. The other one definitely does not. So now that we've got those headers on, and those are nice and straight, let's stick some extras along here, just so that we've got a little bit of expansion later, should we want it. I'm not going to go as far... Oh, focus please. I'm not going to go as far as reset, receive and transmit, because they're all available over here anyway. That one. And we now have a new header that we can pop into there. That'll work just well, I think. And it should be easier to balance this time because I've already got a header. Unless, of course... Oh. Oh, what kind of psychopath does that? You got through-hole... well, through-hole holes. Through-hole holes really should stay on the 0.1 inch pitch. I mean, come on. Oh well. It'll be fine. It'll be fine. Let's just take that off. Pop that in there. And if these ones are angled a little bit forwards, then I don't mind, because they're going to be quite close, butted up next to the relays anyway, so. Come on. There we go. Just kind of hang that off there. Not that way. We want to solder it this way. Oh, and of course that won't fit because the existing headers are in the way, so let's try and pull those back out again and put them on the end of the breadboard. Wow, who'd have thunk this would be the challenging bit? Okay, 9. So again, on this far end. There we go. Much success. Let's see if I can reproduce my earlier success with a factory finish. Just a tiny, tiny little dab. Tiny dab. Excellent. I look forward to not having to do any more soldering tonight because this iron is getting hot. Okay, I think that's about ready. Now, is it actually about ready? Or am I going to make another massive mistake? Except this time I'm going to do it 10 times and it will be bloody impossible to remove. Let's go through a checklist of am I sure about this? And I'm probably not, because I'm very rarely sure about anything, but here we go. So, I've got my FTDI interface, I've got my expansion headers, I've got my SPI interface, I've got my ground link, power input. I think I'm going to solder some wires onto the underside of here and use that as the power in. So the VCC on here will actually be powering the VCC on there. And then I've got A6 and A7 there. Should I put those out onto a header? You know what? It does no harm to do that right now. So I'm going to do it just in case I find a reason why I need them. You know what? It's just going to have to be slightly wonky. But I'd rather it be slightly wonky and available than not available at all. So let's just do this now. That'll do. Again, not great, but sufficient. So, popping those onto there. And I think we are almost all ready to go. So, let's solder that ground link back on. Which should be a little bit easier now because it's been tinned. Let's pretend like it was meant to happen that way. Oh no, my solder's stuck. There we go. Get these headers on. Cool. Oh, sorry. Knocking the camera again. I really have no idea how the likes of Julian Eilert and Big Clive managed to get such stable video. I've got a tripod here and it's holding the phone out on a monopod. It's the only way I've been able to hold it all together, but it does mean it's very susceptible to vibration. Cool, that's on. I'm committed now. So I think I'm going to keep those two headers open so that I can use them as a power port. So I've essentially got a power port and a data port that I can hook up either a real-time clock or some sensors or a whole bunch of things to. And I'm going to solder the power input onto the back. Now I do actually have a DC barrel jack already soldered onto some wire that I used for my prototype version, so let's have that off it. Okay. And let's get these leads tinned. I wonder if I can Big Clive this. I don't think I can, and I have no idea how he manages it. Now it comes with practice, but you've got to be able to do it the first time in order to practice it, right? Oh, okay, hang on, maybe. This wire's hot! But it is tinned, so close enough. Clean that one off. And do a similar thing again, except this time I'm going to endeavour to not almost burn myself. I think the issue is this is a slightly thicker stranded wire, so it tends to soak up more heat. I said maybe I'm just tinning wrong. Again, that'll do. It's not pretty. So this was ground, the second one I did was ground. Can I just confirm that? Yeah, this one is the center pin, and this one is the shielding. So let's try and put the ground on first, because it might be trickier. Please solder onto there before I burn myself. Nope. I'm not having it. Maybe I need to flow some new solder onto this one. Hooray! Probably should have routed these wires through that hole to give them a bit of strain relief or something, but again, it's done now and it's not a big deal. So, put those together. Excellent. Okay. Okay. I think we might, just might, be getting somewhere. Right, so we've got all this done. I've added a few little nylon screw sort of standoff feet type things to it, just to keep it from scratching about. you know, with these, yeah, not nice. Also, these wires here soldered on. I'll probably put some hot glue over those, but I can't lay my hands on the hot glue gun right now. It's here somewhere. So let's test it. Let's make sure that it works. Now, I know this video is getting on a bit. I think we're probably approaching about the half-hour mark. We may even have gone over it. So I'm not going to write any comprehensive firmware for this right now. We can do that another time, but I just want to see that it works right now. So if we have a look at this, yeah, okay. So there's, sorry, there it is. There's pin 13. So we'll start off, thank you. So we'll start off just by sticking the initial Arduino Blink example sketch on here and get it to just click a relay on and off, and then we'll extend it to all of them and just ensure that they do all work the way we expect them to. The code's not going to be pretty, but it just needs to click 8, 16 on/off times. So let's do that. So I've got my, here it is. I've got my TTL serial USB cable, and yeah, ground is right there. So I'm gonna, let's just drop that end. There you go. Put the black wire. Oh, heat shrink's coming off. There we go. Black wire to this side. So let's just pop that in. Connect that up. There we go. Lovely. Don't want to get that the wrong way round because it is a non-polarized connector and it's not a keyed connector, so you could put it in the wrong way around and do bad things, but we're going to put it in the right way around and do good things. So let's get this plugged in. Hope that it doesn't blow up my laptop. Ah, okay, it's doing something. I'm not sure what. That was a bit weird. I don't know what firmware's on here, so let's just upload this Blink sketch and see what happens. Okay, thank you. Oh no, there was an error. Oh, okay. This is a new install, so... Ooh, what kind of board is this? Buggered if I know. Could be a Nano. Just try it. Nope, it's not a Nano. It is a, oh wait, I'm pretty sure these are 328s. Sorry, I'm trying to see the, yeah, 328, okay. 328, try it. No? Oh God, let me try and figure out what this is. Let's try a 2009. Seems, ah yes, that seems better. No, did that not work? Maybe it doesn't work. Maybe I've screwed it from the start. No, it's gotta be one of these. Get board info? Unknown board. Well, that's helpful. Ah, old bootloader. Maybe that was it. That work? No? No, doesn't seem happy, does it? Does it just need recessing or something? Just trying to have a look underneath and see if I've accidentally shorted something that I didn't mean to, but it doesn't look like it. I mean, yeah, the board is kind of resting on top of those opto-isolators, but that should be fine. But I don't see any of the output that, you know, the uploading output. That's not normal, is it? I mean, I'm supposed to see that, I think. Okay, well, let's try just uploading Blink to that one and see what happens. So let's unplug this one, and I've got another cable, USB cable. Plug that in there. Now I think this is a different. No, it's a 328p. Okay. Oh, this one's a CH340 or whatever it is. I might need to install the driver for that. Yeah, CH340. Give that a go. Is that the same? Go away. Problem uploading to board. Device busy. I'll show you busy. Alright. You still show that device? No, okay, it's definitely gone. Cool. Put that in. So, this should be the new recognized USB 0. There we go. Okay. So, yeah, there's the LED blinking. A little L LED there. So, I guess it's normal that I'm not seeing the output of the AVR dude output. Is there a setting for that? Oh, show for burst output. Excellent. Yeah, go on. Why not? Yes, that's what I was expecting to see. Right, okay, now. Oh, man, that was a stiff port. Plug, port, plug, whatever, I'm not sure. Let's try that one again. Clickety click. Oh, okay, fine, be that way. Stop it. No, that's actually just weird. There's something odd going on there. That's bizarre. Okay. It doesn't work. I'm gonna have to look into this. I'm gonna cut this video short here now because this is just gonna take a while. I'll get back to you when I figured it out. But wait, there is more. Look. Click, 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 click. Yeah, it seemed to be power. You know, when in doubt, when you've got something that's just behaving weirdly, it's power. So I should probably get a meter out and measure some things. You know, thou shalt measure voltages and all that. But yeah, that appeared to be the issue. So I'm running it off my power supply. I've got it's down here. I don't really have space on the desk. I've got one of these things. So that's providing 5 volts directly to it, and yeah, it's fine. So how can we get around this? How can we program it while also giving it enough power? And the simple answer to this is to just simply connect the grounds together. So where's my, oh, there you go. This will be a suitable pokey. So all I really want to do is to just remove the ground, sorry, the power from here. This may actually have been what this was about. I don't know. We'll see. But it's just me faffing around at my desk really, and a bit of a learning experience. So there we go. If we pull that out, it should now be perfectly safe to attach to the computer, and we won't be competing with power supplies. We'll connect the grounds together so that they both have a common reference and they can communicate, and the electrons or the angry pixies will dance less angrily. But it's very important that you not have that connected, otherwise things will go fizz and bang. So, in fact, you know, I'm terrified to do this, but it'll be fine. See, why am I terrified to do this? Because I've plugged this into my main laptop, and my God, if you worked at my office recently when my last laptop died, you will know firsthand just how much I cannot handle that shit. I should really give some thought to getting a second machine. So maybe just something for fiddling with all this with. You know, if I blow out a USB port in that, it's a Dell 15-inch XPS, I'm going to be a very, very unhappy bunny. So yeah, I should probably do something like that. But anyway, yeah, the screen recording's still going. So we've established that, yeah, this one, because if I feel it, yep, that one's clicking away, so that one's fine. And the pin mode. So this is going to be 10 through 13. So 10. In fact, you know, let's just get rid of the crud. Don't need that. 10, 11, 12, 13. 11, 12, 13. And then a 1, 2, 3, 4. So A1, A2, A3, A4. Okay. Right, let's start with 10. 10. Make that a variable. Lose that. Cool. Int delay time is, let's just make it half a second. And we are going to just duplicate this. So that's 1, 2, 3, 4, 5, 6, 7, 8. I did say the code for this was going to be dirty. And filthy it is. Actually, it could be filthier. I am using a variable. A1, A2, A2. Wow, that ticking is putting me on the spot. A4. A4. Cool. Upload. Do the thing. Nice. Though it does appear that this in fact is out. What do you call it? Active low. But I'm confused because when I leave it low. Oh, yeah, okay. Sorry. So I have this thing where my brain just loves to invert things and I don't see that it's happening. So active high, active low logic for me is interesting, to say the least. Does it start with everything? That was interesting. Okay. So can I start all these as... Oh, Arduino, how I wish you were Vim. Hi. Is that what I need to do, maybe? Yeah, there we go, that's more reasonable. I was a little bit concerned there that we were going to have a problem with the relays, you know, doing crazy things when you first start up. I mean, if I reset, what will this do? No, okay, yeah, as long as I initialize everything correctly in setup, it will be fine. Yeah, okay, cool. I'm going to stop that from clicking away now because that's getting immensely annoying. Yeah, just wait for the big old capacitor in the power supply to discharge. So yeah, cool. Hooray! It does actually work. It turns out that I can't provide enough power over the USB to run any of the relays. Which is odd, because I did have a little bit of a play with this beforehand, and I'm sure I did it before. I'm sure it did work. So, yeah, that's very odd. But it doesn't seem unreasonable. I mean, you know, I'm running relays, they're, well, I'm going to say reasonably beefy loads. I mean, they're not, but they are compared to, you know, a little chip or something like that. So, yeah, well, I don't know, there it is, there it works. We've got some extremely dodgy code that I'm not particularly proud of, but there it is. We will revisit this another time, where we shall write some code for it. Some nice code that does timing and things. I was actually thinking about this. I'm not actually that convinced that something like this really needs a real-time clock. The internal timer will probably be sufficient. It's not like I need super accurate resolution, but you know, I do have the real-time clock, so I suppose I may as well use it. But yeah, I was considering, you know, a little display might be a bit more useful on this to say what it's doing and when the next change will be, but that's just feature creep, so let's not do that right now because I've only just got this together. And yeah, this isn't Plum work, so I should probably do something on Plum next. But yeah, there you go. There's a bit of fun. That was alright. I am pleased with this overall. Yeah, I am. I would have been nice if there were, you know, something a little bit more graceful than just yanking this wire out. But to be fair, I've taken a couple of off-the-shelf modules, smushed them together and gone, yeah, that seems to fit. So, it is what it is. If I were designing PCBs for a project like this, then I would definitely have some other kind of provision for dealing with that. Which would probably just take the form of not hooking up that pin. Yeah. But anyway, I'll stop rambling and I'll let you get on with your day.